the unknown. Well, we're not going into the unknown today. We're going to go into the known about triangles and angles and triangles, actually. So our learning target for today in this lesson 21.1, which I'm going to change the title from angle relationships to angle relationships in triangles. I'm going to draw a triangle instead. Because we've learned about angle relationships just with like parallel lines, and now we're going to go into talking about triangles, some things that you do know already probably, and some things that you may not know. And as you can see, my theme here was the Frozen 2 specifically. If you've ever seen that movie, if you haven't, I don't know where you've been, if you've been living under a rock, but man, I've seen that way too many times. Anyway, success criteria. Really, it's three things that we're going to talk about today. Know that all three angles in a triangle add up to 180 degrees. Know that the exterior angle is equal to the sum of the two non-adjacent interior angles. And know that if two angles in one triangle are congruent to two in another, then the third is congruent as well. If none of that made sense to you, I'm going to explain it right now. So no big deal. So here's lesson 20. Oh, shoot, now I have that wrong too. It's 22.1. All right, in your notes, this is actually page 198. If you want to follow along, actually, you should follow along page 198 in your notes. Take some notes here. So let's start with this first part. What special relationships are there in triangles? Where one that most people do know is how many degrees there are inside of a triangle. Could you tell me how many degrees are there? Well, if you didn't know, inside of a triangle, we'll read this through. You've seen triangles formed by parallel lines and a transversal. They have important relationships. Angles and triangles also have similar relationships, and one of those is that we're going to talk about how the sum of three angles in any triangle is 180 degrees. It's going to come up later, but I want to talk about that now. If you have a triangle here, the three angles inside, so in this case, we would say the measure of angle 2 plus the measure of angle 4 plus the stop moving on me, plus the measure of angle 5 all add up to equal 180 degrees. And that'll happen for every single triangle. Okay? So that's one of the most important things that all the other stuff that we're going to work on comes from that, essentially. So you can use this angle relationship to help you solve problems about triangles and other polygons. For example, you could find the measure of each angle in an equilateral triangle. But we're going to talk about two other special relationships in triangles that work in all triangles. So it says the measure of an exterior angle of a triangle plus the measure of the adjacent interior angle is equal to 180 degrees. So what that means is if I were to take a triangle, and I'm going to add a new slide here. Whoa. Let's undo that. Here. If I would take a triangle, if I want to make, well, let's just have angle 1, angle 2, and angle 3. If I want an exterior angle, all I have to do is extend one of the sides out a little bit, and that creates an angle right here. We'll say is angle 4, and that's called an exterior angle. Okay, so if you want to draw that in your notes, you can. That's an exterior angle of a triangle. And what we're saying there is that angle 1 and angle 2, sorry, angle 4, the exterior and the adjacent, meaning the one that's next to it, add up to 180 degrees. And you should know that already because this is called a linear pair because it makes a line together. Now we're going to use that relationship and go in a little bit more in depth about exterior angles because you can figure out that, well, here we go. Here's a definition for exterior angle. It's an angle formed by extending one side of a polygon past a vertex. We just did that. And there's a picture. Beautiful. The fact that we're going to read this through right here. The fact that the sum of the measure of the three interior angles is also equal to 180 degrees. It will help you find a relationship between an exterior angle and the other interior angles. So in this diagram, in your notes, we're talking about W and then the other ones, the ones that are not next to it. So they're called non-adjacent. So you will reason that in any triangle, the measure of an exterior angle, such as W, equals the sum of the measures of the two non-adjacent interior angles, so Y and Z. So remember, sum means adding. So essentially, if we know that W plus X is 180 degrees, what we're saying is, so that's 180 degrees. We're also saying that, I'm going to slide this over a little bit, inside of a triangle, X plus Y plus Z is also 180 degrees, because it's inside a triangle. And if they're both equal to 180 degrees, they'd be equal to each other, right? They're both 180 degrees, so that makes sense. Now the thing that's the thing that's in common between both sides is the X. So if the X is in common between both sides, really we can eliminate that X from both sides. It goes away. And what we have is W, or that exterior angle, equals Y plus Z, or the two non-adjacent interior angles, the ones that are not next to it. So that's our second important relationship that we're learning about triangles. An exterior angle is equal to the two non-adjacent interior angles, if you add them up. Okay? Let's turn the page. Now we're on page 199. On page 199, we're going to start off with this thing at the top. It says, if two angles in one triangle are congruent to two angles in another triangle, then the third angle must be equal in both. And let's just take a step back to think about that for a second. Because it may be wordy, but it really does make sense. We're going to write this whole thing out based on these two triangles to the right. So we have a triangle ABC where we have a 20 degree and a 115 degree angle. And triangle F or DEF is a 20 degree angle and a 115 degree angle. So if we know that all the angles in a triangle add up to 180 degrees, which we said right away, then right here, the 20 degrees plus the 115 plus angle C should add up to 180 degrees. So just what's stated here. Okay, if you add up the 20 and the 115, you get 135. So I'm just going to move this over here. That would be, because they skipped a step here, I'm going to show that 135 plus, why did I write 113 now? All right, so 135, when you add those two together, plus the measure of angle C equals 180. And we know to solve for something, like the measure of angle C, we have to, in this case, since it's adding 135, we subtract 135 from both sides. And that's what they showed in the next step, then 180 minus 135, and that gets you 45 degrees. So that means our angle C is a 45 degree angle. So then let's find the measure of angle E. We could do the same thing in this triangle. We know that it's still a triangle, so all the angles still add up to 180. So we do 20 plus 115 plus the measure of angle E equals 180. You do the same exact stuff. You add in the 20 and 115, you get 135, and subtract that from both sides. You end up getting the measure of angle E is also 45 degrees. So that means that the measure of angle C and the measure of angle E are the same, or those two angles are congruent. And that's what we're saying here. If you know that two triangles have two of the same angle measures, then the third one has to be the same. It just makes sense. Because no matter what kind of the size of the triangle, the angles always add up to 180. So when all three angles of a triangle are congruent to three angles in another triangle, the two triangles are called similar. And we've talked about similar versus congruent. Similar means it's the same shape, just a different size. It looks similar, but it's a bigger or smaller version. It's like it's dilated. So corresponding sides are proportional. The triangles above show this, and we're going to get into that more a little bit in our, I think it's our next lesson. Just looking ahead though, um, the sides, so if AB corresponds with FD, I'm going to highlight those in green here. If you took AB over FD, like divided them, that should be equal to whatever BC, so let's just say in red, is divided by DE, because those are corresponding as well. And that's how it'll work when they're similar triangles. Okay? So, I'd like you to try this reflect question on your own then. It says, in triangle PQR, the measure of angle P is equal to 30 degrees. The measure of angle Q is equal to 60 degrees. So that's labeled here and here. In triangle STU, the measure of angle S is 30 degrees, and the measure of angle T is 60 degrees. So that's labeled there. So the question is, how do you know that the measure of angle R is equal to the measure of angle U? How can you prove this using the fact that the measures of the angles in the triangle have a sum of 180 degrees? So what I'd like you to do is to find those angles and show that they are truly equal to each other. So I would like you to pause the video and try that on your own. All right, if you tried it, hopefully you were able to work it out that in a triangle, they all add up to 180 degrees. So I wrote 30 plus 60 plus the measure of angle R has to equal 180. And for the triangle on the right, 30 plus 60 plus the measure of angle U equals 180. So the only thing that's different is the one that we're trying to find. So logically, those should be the same, right? And you could then show it by adding things up. So this would be 90 plus the measure of angle R equals 180. This one would be, if I added these, 90 plus the measure of angle U equals 180. And then to solve it, if I subtract 90 from both sides, or in this one I'll subtract 90 here on both sides. It cancels out the 90 on both sides, and you get the measure of angle R equals 90, and the measure of angle U equals 90. So that shows and proves that those angles are congruent. And that's actually a statement of fact, something that we know is true, as we have described right here. And that takes us all the way back to our learning target and our success criteria for angle relationships and triangles. The three big things there. One, we learned that all angles in a triangle add up to 180 degrees. Okay? Two, we learned that the exterior angle, so that's when you extend one of the lines, it forms an exterior angle, that is equal to the sum of the two non-adjacent angles inside the triangle, so the other two angles. And three, we know that if two angles in one triangle are congruent to two in another, then the third angle in each triangle are also congruent. And that's our lesson for 22.1. And we have one more question for you. Do you want to build a snowman?